is January 24th. I am Hanson Sue and here with Eric Bier. So, Eric, can you tell me a little bit about how you started at PARC and how you got involved with the Cedar project?
Sure. So I first encountered Cedar in 1981. It was my second summer at PARC as a summer intern. And I was working that summer with my host, Rick Cattell, on databases, and he wanted them done in the Cedar programming environment. So that was my first experience with it. The following summer, I was there for 3 summers as part of a program with MIT. They called it the 6A program. It was a co-op program where you work 3 summers and a fall at a company and then do a master's thesis based on about your last 6 months of work. So as I say, my second summer, it was using Cedar with Rick Cattell. My third summer, my host was John Warnock, and I was in a lab, I think it was the Imaging Sciences lab. Chuck Geschke was the lab manager at that time. And I was working on a solid modeling system that I called Solid Views that then became my master's thesis at MIT. And so I encountered Cedar. I encountered it largely on the Dorado computer, which I'm sure you know about here at the Computer History Museum. And I still remember the first time I encountered Dorado. At that time, they didn't have Dorados for everyone, so you had to sign up for them. And I signed up for an hour slot with a Dorado. I actually had to take a shuttle bus from my office down on Hanover Street to the building on the hill, 3333 Coyote Hill Road, to get my 1-hour slot with the Dorado. And actually, that was the summer before when I was using Smalltalk. That was my first encounter with the Dorado.
Huh.
And I had to ride the shuttle bus that summer. And what I remember was almost laughing out loud because I wasn't waiting for the computer, it was waiting for me. So the Dorado was a sweet machine. They were built with emitter-coupled logic, which meant that they were fast, but also that they ran really hot. So you didn't have a Dorado in your office. You had the Dorado down the hall in an air-conditioned room, and PARC had a whole lot of cables running in the ceiling.
Mm-hmm.
One of the things that I thought was really interesting about Cedar was that it was an environment that was intended both for researchers and for staff, both for programming and for making publications.
Mm-hmm.
So what I've got on the screen right now are examples of documents that have pictures in them, that have nicely formatted text and so forth. The researchers used Cedar, but also the administrative assistants, also the artists and so forth.
Could you maybe go back and explain to someone who's not familiar with this environment what Cedar is?
Sure. So Cedar is a combination of things. It's both a language, also called Cedar Mesa, a programming language. When people asked about it back in the 80s, we used to tell them it's kind of industrial strength Pascal. That kind of gives you a feeling for what the syntax is like.
Mm-hmm.
And we'll talk more about the Cedar language later. But it was also, of course, a set of applications, a set of libraries that people could build on. And Cedar was a very successful experience in code reuse. The way that the Cedar programming language works, it pretty much forces you to package your code in a way that other people can use it, and other people did. There were dozens of people in the Cedar community, and we were constantly building software on top of each other's software.
Mm-hmm. So it was a pioneer for the modular programming kind of paradigm?
Yes, I think that's fair to say. It was certainly very modular. And people built a lot of different kinds of applications on it. We were just talking about some of them. Mm-hmm. So there were document processing tools, there were email readers, there was all kinds of debugging tools, publication, two-dimensional graphics, three-dimensional graphics, VLSI design tools, databases, the list went on and on, networking software. It was all done in Cedar. And because it was a fairly close-knit community, and because of the way the programming environment itself worked, you could constantly be building on other people's software, and even sometimes you would discover a bug in someone else's software, and rather than bother them with it, you would just fix it. And it meant that if you found something wrong and you couldn't fix it yourself, it was easy to find out who was responsible for that and get a problem fixed quickly.
Mm-hmm. And what was the goal for the group that developed Cedar? What were they trying to do with the environment?
Right. So PARC put a large investment of time and effort into Cedar. And one of the reasons they did that was this feeling that whatever we were going to do research on in the Cedar community, that we wanted to be able to do it very productively. We wanted to stay on the cutting edge of whatever research topics we were working on. And in order to do that, we needed to have a programming environment that was very productive to work in. And Cedar was very successful at that.
And there were two other programming environments at PARC as well, right? So,
Correct.
Smalltalk and InterLisp.
Right.
And so how would you compare these with those environments?
Right. So obviously the languages are very different and what they enable is very different. So Smalltalk, very interactive. You type a line of code straight into your terminal window and immediately execute it, right? So that very interpreted interactive way of working. InterLisp, because of the way the Lisp language is with the very simple syntax, you can be generating code and then immediately running the code that you generated. So the folks who used InterLisp, were often doing the artificial intelligence type of stuff. What Cedar was really strong at was a strongly typed language with separation between interfaces and implementations, which meant, as I said, that it was tremendously good at allowing code reuse. And the code that you produced was, fairly robust and likely to, if it compiled, it was probably going to run. And so it was a good environment for building things that were easy to productize, because you already had them implemented in a language that encouraged creating fairly robust hardened code.
What machines did you have access to, and could you compare them?
Right. So my first summer at PARC, I had an Alto at my desk, and I think it was Andy Daniels was working next to me, and he had a Dolphin, which was a newer machine. So it was enough faster, I don't know, 50% faster, 2 times faster or something like that, that it was worth it when he was going to be out of the office. He would tell me, okay, you can use my Dolphin now because I don't need it. But the Dorado was then significantly faster than the Dolphin. So, as I said, the Dorados wait for you, not the other way around.
So.
And by the way, that first Dorado that I signed up for, those machines were 1 million instructions per second. Now, that's not quite as slow as it sounds, because those instructions did a lot. That wasn't just clock cycles. They're microcodable machines. And each Dorado on the sign-up sheet said how much memory it came with. So most of them, I think, had 768 kilobytes. But if you were lucky, you could sign up for the big Dorado that had a whole megabyte of RAM.
So then Cedar ran on the Dolphin and the Dorado and other machines in the D machine series, but not on the Alto?
I don't think Cedar ever ran on the Alto. I don't know that it ever ran on the Dolphin. Certainly the Mesa language did run on the Dolphin, because I think that's what Andy Daniels was coding in that summer. But I'm not sure that Cedar ran on the Dolphins.
Oh, okay. Did you want to talk about how Mesa developed into Cedar?
The part of it I remember was that Xerox developed the Mesa language and programming tools for the Mesa language, and they used it for some Xerox products, right? So when the Xerox Star came out, which I think was around my first summer at PARC, 1980, there was a big party out on the patio to celebrate the release of the Star that summer, as I recall. That software was written in Mesa. Mesa didn't have all the convenience features that Cedar Mesa eventually had. So you didn't have the automatic garbage collection, and of course that has a big impact on how you do programming with it. So you did a lot more programming where you explicitly worried about pointers and allocating storage and so forth. And that was one of the big improvements when we moved to Cedar.
To help us out today, we have several PARC alumni here. Paul McJones, Chris Jacobi, and Nick Briggs.
I'm Paul McJones. I was actually sort of across the street at Xerox STD from 1976 to 1981. I was working on the Star Office Automation System and the Pilot Operating System, which became a low-level building block for Cedar later, but I left before Cedar was really a thing.
I'm Chris Jacobi. I joined PARC in 1983, and being one of the customers of Cedar first, I wrote the VLSI design tool in Cedar, which might have been one of the largest in code size. But later on, I got even closer to Cedar. I wrote parts of the compiler and parts of the Windows system.
I'm Nick Briggs. I started at PARC in 1984, and at that time was working on the Interlisp system. But later on, I became a customer of the Cedar imaging code as part of the DocuPrint printing system.
Another couple of words about the origins of Cedar Mesa. We were pretty happily using Mesa in the mid to late 70s for the product development. As Eric said, it didn't have garbage collection. We had so little memory, we had to preciously allocate each little byte. There was an interesting discussion going on at PARC across the street. I wasn't directly involved, but I got to read sort of the minutes, which was to come up with, there was sort of some controversy at PARC about getting everyone working together using those packages that Eric had described. And yet there were these three different languages. So some of the people felt it would be great to try to unify the capabilities of the three different programming environments, which Eric has already described their attributes. So there was an effort called the Experimental Programming Environment Research Project, and it was really looking at the three languages and trying to decide, could one of them become sort of the PARC standard language? And I think Cedar Mesa clearly came out of that, and by the 80s was, played a dominant role. And yet I think the people from Smalltalk and Interlisp felt not exactly railroaded. They definitely contributed a bunch of ideas to what went into Cedar, but they weren't convinced that that was going to replace their own language.
All right, so let me say a few words about what we're looking at here. So if I were giving this demo back in the 1980s, I would be doing it off of the screen of a Dorado. In the early 80s, that would have been a black and white screen. Right now what we're doing is I have a MacBook Pro here at the Computer History Museum. It's running X Windows. We have a VPN connection to a Sun Microsystems machine at PARC that's running a version of Cedar that works on Sun Microsystems machines, that works on Solaris. And of course, then what you're seeing on this screen here, what Cedar is producing. So to introduce you to Cedar, of course, the first thing you see with Cedar is the window system. And we're looking at several windows here. There were actually several window systems developed for Cedar. There was one that Warren Titleman did called Docs that had a lot of functionality to it, but ended up being somewhat slow. Scott McGregor did, in response to that, I think, a lean and fast window system that he calls viewers. And so the windows that you're seeing here, we called viewers. If you kind of look at the screen from top to bottom, you're seeing there's a sort of a status bar up here at the top and some buttons. If I press this button called Command, we get a new terminal window, or what in Cedar was called a commander. If I press the New button, we get a new text editor window. That's the Tioga text editor. And then what you're seeing going down the screen, again, these are viewers. You can have many viewers open at the same time, and Cedar was kind of optimized so that you could have many windows open at the same time. In fact, you could make the windows very compact, so you could even get rid of the small number of menus that are at the top of each window to make each window very efficiently use the screen space available. And in fact, there's another menu that gives you more functionality that I have collapsed by default. It was a very configurable system. There are configuration files where the user could say what defaults they wanted for various things, including what menus are visible. Down at the bottom of the screen, we have icons. So when you take a window and close it, it then becomes an icon at the bottom of the screen. And later on in Cedar development, some color was added to the icons, generally to show the kind of application that you were working with. And as you see, the icons have different patterns to them, which also suggests which exact application it is you're running. And Cedar came with a fun little tool called the icon editor, where you could, one pixel at a time, change what your icons looked like. So one thing that strikes you immediately about the viewer's window system is that it's a tiling window system, right? Most of the window systems we use these days are what are called overlapping. You have a window and then another window on top of that and another window on top of that, and you drag them around and resize them and so forth. So viewers does tiling, which means that whenever you open a window, it goes into one of the two columns. So there's a left column here and a right column here. You can switch which column a window is in. So I've got this little right arrow here. I can move that window over to the right, and now it's in this column. If I'm distracted by the other windows in that column, or I want more space for this window, I hit the grow button. That viewer now becomes the whole column, and all the others become icons. You can change where the line is between the two columns, adjusting it like so. And there's a lot of machinery in Cedar for remembering which windows you had open before. So if I close this window, actually I think I have to destroy it. Let me try that. If I destroy this window, it remembers, oh, well, there were two other windows in that column when you pushed them out to make that window big, but now that that window doesn't exist anymore, let's assume that you want them back. So there's sort of a number of clever little efficient features like that. So Chris Jacobi and I were talking the other day about some of the things that we still miss about Cedar to this day. And one of the things that we miss is the way that the scroll bars work. And let me show you that. So what we're looking at here is actually a document written using the Tioga text editor that was written to be a conference paper. And notice that the scroll bar is off to the left-hand side instead of the right-hand side where it would be in most systems today. Cedar users view that as a very good thing. One of the great things about having the scroll bar on the left is that when you have a text document, and when, in particular, when you're working on software, so let me open a software module for a second. So here's a software module. One of the things to notice about software is that the text is more likely to be on the left-hand side of the window than on the right-hand side. Often the right-hand side has a lot of white space. And since what you're doing when you're working on a document is you're often pointing at things with your mouse cursor, you're not going to be pointing at the white space, you're going to be pointing at the text. And the text tends to be on the left. So you're already near the left-hand side of the window. It's just a small motion to get into the scroll bar and start using it. The scroll bars also had some nice features where if I want this particular piece of text to go straight to the top of the screen, it's a single button click to do that. So there's not a whole lot of scroll and see what happened, scroll and see what happened. It's a whole lot of clicking. The Tioga text editor also has levels, as I showed you before, and there are these menus here that say, I want to see fewer levels, so you're basically getting an outline view of this document. Now I want to see all levels, and it expands out and shows you everything. But you don't actually need that menu because those commands are also built into the scroll bar. So if I, let's see, there we go. Holding down the Control and Shift key collapses everything as I click. And then holding just the Control key expands things back out, and at the same time moves what I wanted to go to the top of the screen to the top of the screen. So after you use Cedar for a while and kind of become an expert user, a lot of these things become second nature, and you get really efficient at navigating around in documents. And as I said previously, not only is this a good system for code, but also a good system for publications. So here's that same conference paper that we were just looking at, but I now just collapsed all the levels, and now we see an outline of this conference paper. And if I want to jump straight to section 5 and expand things out, I can go ahead and do that with another click. So definitely something that Cedar users miss about Cedar. By the way, if you want to jump to a particular position in the document, like 3/4 of the way down, you just use the middle mouse button to do that. The cursor changes to this little arrow to show you that you are thumbing, and you go straight to that part of the document.
So Cedar made extensive use of all 3 mouse buttons in the interface.
Yes. Thank you for that prompt. Exactly. So a lot of the operations in Cedar use some combination of the left mouse button, the middle mouse button, the right mouse button, and the Control key and the Shift key. Right? So with Control and Shift, that gave you 4 combinations plus 3 mouse buttons. Basically gave you 12 commands in any given context that you could trigger just with those keys and the mouse buttons. And Cedar made a lot of use of that, as you'll see as we go along. I wanted to show you moving a window to the top. There you go. So again, without changing the content of one of the columns of the window system, you can change what order the windows appear in. Another thing to notice, and this is particularly true, or particularly remember this with respect to writing software, is that the fonts that are used are readable but small. And as a result, one felt there was no problem in opening many windows at the same time. So if you were writing a piece of code and you thought, well, I kind of need to copy some bits of code from module A and module B and module C and move those all into module D, then you could just open those 4 modules all at the same time and move things around. So let me give you a feeling for that. So there's another module. And let me do, let's see, that doesn't exist. Okay. So there I've got 3 modules open at the same time. And I'm able to see quite a number of lines of each one. If I wanted a piece of content moved from one window to another, I can go ahead and do that. So maybe I want to move a piece of content down here. And maybe I also need something from this module right here. And I just pull that all in. So one of the things that I was just demoing without talking about it was this command openr, these commands openr and findr. I believe the R is for release, and open in the sense of open something for editing or viewing, find in the sense of get me a listing of everything that matches a pattern, and the R means, but don't look in the current directory, look in the release directories of Cedar itself, wherever they are on some file server. So for example, if I remember that there are a number of files in the Cedar release that end in the extension df, I can go ahead and ask the system to find all those. And it's telling me where they are on some file server somewhere. So there is a path that begins with Cedar 13.0, and somewhere else in Cedar is a mapping from that path to an actual file server somewhere. And then there's a subdirectory inside of that called top, and that's where all these df files are stored. And I'll talk more about df files later. But the companion command openr means if you find a file that matches this pattern that I just typed, then please open it in the Tioga text editor and let me see it. So if we remember, for example, that the Tioga text editor itself has a documentation file, the Cedar convention says that the documentation for a package always ends in the letters DOC, so not hard to remember. And I said openr Tioga doc, and it found that for me in the release wherever it happens to be. And I can now go and read the user manual for the Tioga text editor and find out how Tioga works. Now I wanted to tell you a little more about the Tioga text editor itself. Tioga is really important in Cedar because it's everywhere. So obviously, it's in Windows, like this Tioga window here, and you can see by the fact that this document name ends in .tioga that this is a Tioga file. By the way, notice another efficient use of screen space. That little bar at the top of the window is both used for the path name of the file, but there are also some buttons underneath it. So Tioga is used in Windows, but Tioga is also available in many other places in Cedar. So for example, this is a terminal window. In most modern operating systems, the terminal application has a fairly stripped down text editor with only a small subset of the commands that would be available in a full-fledged text editor. But this has got Tioga in it. So I can do Tioga shift select within that command tool and pull bits of text from the command tool itself or from other documents on the screen. I believe I can even change the looks of things here. So there we go, right? So I just made that text bold because, well, this is the Tioga text editor. It's even available in the little tools that you do to do search and replace. So this tool here, the edit tool, is kind of a companion to Tioga. You generally only have one edit tool on the screen at a time. And then you apply it to any windows you happen to have open. So for example, one way to do a search in Cedar is to say, well, I think the word memos is in this document somewhere. Let's see if I can find it. And that's one way to find it. And if I want to do a search and replace, then of course I can put in another piece of text here that I want to replace it with. Now, I could change the text, of course. That would be the common thing to do. But I believe it's also possible to change the looks. So let me see if this is how you do that. I haven't done this in a while. All right, so match anywhere, match literally, do replace, do operations. Okay. Obviously, I haven't done this in too long. But you can also use the looks to search for pieces of text that have a particular look to them. So let's see if I can get that to work. All right, and I don't need anything to replace it with. Oh, right, looks. That's what I need to do. All right. So what if I just want to find everything in the document that's bold?
Wow.
So we can go ahead and do that.
Yeah.
So the edit tool is very powerful. And now I think we can also do the edit I was planning. So let's see if I can make that bold. Do a search. There's memos. And there it's replacing both the text and the looks of that particular item. By the way, Cedar does have undo. Good old Shift Escape gives you one level of undo in many of the applications in Cedar. And if you want to get rid of all of the edits that you've done recently, you can just hit the reset button and go back to the on-disk version of that particular file. As you can see, the edit tool has a whole lot of functionality, and I won't go through all of it for you. But I will point out some of the interesting things. So let's go to my conference paper again. And let's find out some things about this document. So here's some text that's bold. Why is it bold? Well, it's bold because it has the letter B associated with the looks. Well, B stands for bold. So someone just applied the bold look directly to those characters. What about this? This is bold. But it doesn't have the bold look applied to it. What's happening instead is that there are style sheets behind Tioga. They are even cascading style sheets. And so if I do get here, it tells me that that there's a style applied to this called Chi2 column reduced, Chi in the sense of the Computer Human Interaction Conference, the ACM conference. So we had a style sheet for writing publications for that particular conference. And this particular paragraph is a heading level 1 or a head 1. So kind of a lot of the style functionality that you would expect. One last thing I'll show you about the edit tool is the ability to do macros. So for example, if I wanted to select something and then I'm going to move the caret to a position after that object, and then I'm going to make it look bold, and then I'm going to add a few characters to it. I can then ask Tioga, what operations did I just do since the last time I selected something? It remembers all of the operations, and it will repeat them. So in addition to undo, Cedar has redo. And that happens whether or not you're using the edit tool. So oops, if I just, let me close that. If I just come to an object here, do a few edits to it, maybe I'll make it italic this time. I'll add a little punctuation at the end, maybe put a number. Now I select anything else, hit my escape key, and I'm redoing that edit. So you would often find as you were using the Tioga text editor that you wanted to do something over and over again, and often it would do just what you would hope it would do. One thing about Cedar, some people liked it, some people didn't, was that a lot of the commands required that you make a text selection before you did them. So for example, let's see if I can. So for example, say I want to load a new file into this window. So this window knows that it's in the Tioga files folder. So any other file in that folder is available to me. So here are all the files that are in that folder. And if I come along and, let's see here, I will select a file name, then I'll come and say get. And there's what was in that file. If I want to go back to the previous file, just hit the previous file button and it reloads that again. And you'll probably see other commands in the demo where we use that ability to just select some text anywhere on the screen and then apply it to one of the Cedar applications.
Eric, can you say something about the different mousing model, the insertion point and shift select, copy select, those operations that are quite different from what we usually encounter today?
Yes, I certainly will. Let's do that now. And I think I will do it with some code. So when you're using a computer today, you're probably going to use copy and paste. Copy and paste has become a standard way of moving text around within applications and across applications. In Cedar, there is a more efficient method, and it's enough more efficient that I continued to use Cedar deep into the 1990s, just so as not to have to give that up, along with some other features. But that was a big one. And here's the idea. Instead of selecting something and then clicking a copy key or a copy button and then moving somewhere else and pressing a paste button, what you do in Cedar is you leave your cursor wherever you're working at the moment. So perhaps we're working right here. And now we realize that the thing that we're about to type is already present somewhere else on the screen. So rather than type it again, it would be nice to just copy it. So what you can do is hold down the Shift key on the keyboard. That tells the system that you want to do a copy. And now all of those mouse buttons commands are available in order to do that copy. And let me talk about those for a second. So left mouse, middle mouse, right mouse. We use them all. The left mouse button, you select a single character, any character on the screen. The middle mouse button selects a word, any word on the screen. The right mouse button extends your selection at its current level of granularity. So if I selected a character and I hit the right mouse button, it selects all the characters from the first place to the new place. If, on the other hand, I had selected an entire word and I hit the right mouse button, it selects to the level of words. But we're not done yet, because there's also double clicks. So if I want to select this entire node, as it's called in Tioga, I double click, and in coding like this, a node generally corresponds to a line of code, so double clicking gets the whole line. And now I can use the right mouse button to extend the selection at the line level. And finally, if you double middle click, you get the node and anything nested under it. So an entire branch or entire tree. And if I right click, I extend at the level of entire trees. And in code, that generally means that I can then select a whole number of methods or routines in the code. And maybe I want to take this whole section of code, for example, and move it to some other part of the file in order to group it with some other routines that I've written. So those are the basic selection commands. And now when you hold down the Shift key, you've still got all those commands available to you, left click, middle click, right click, double clicks, and so on. But now you're doing them in the context of wanting to copy. So if I hold down the Shift key and say double click, double left click, I've just pulled in an entire line of code from somewhere else in the file. And more interesting still, I'm now set up with my cursor in the right position to pull in yet other lines from other parts of the file. So instead of copy, move, click, paste, move back, copy, and so forth, it's shift click, shift click, shift click. And you can really throw text around in a hurry with that way of doing things. Anything else I should cover, Nick?
No, I think that got it.
Okay, cool.
If you don't mind, I'd like to add something which is very hard to demo. That's probably you didn't demo it. The commands are very orthogonal, which means if a certain pattern of a command works in one place, the same pattern of mouse and keyboard and double click works in something else. And if anybody wondered how that Eric, after having 16 years not used Cedar, still is able to demonstrate the key clicks, then you see how clever the user interface is done so that there is a small number of facts to remember. It's actually even so good that for me it's 18 years since I haven't used Cedar. I still make errors. I still use Cedar key combinations sometimes on my PC with a tool which absolutely has no idea what to do for that. And another thing which is hard to demonstrate, but Eric said that Tioga is everywhere. I'd like to come with some example for this so that it really becomes obvious. Say, for example, your program runs into an error and writes an error message. Guess what? You can use the Tioga commands to go and edit the error message if you want, because wherever there is text, this is Tioga. I think I know one exception. If in a chip design you have some metal with the pattern of letters, that doesn't work with Tioga commands.
Thanks, Chris. Just a few more things about Tioga, and then I'll move on to some other things. So you may be curious about some of the buttons up at the top of the screen. For example, split. This is a feature that you would love to have in text editors even today, but not all of them have it. It's the ability to look at the file at several different scrolls at the same time, right? So maybe I need some code from copy circle, but I need it up here at the top of the file. I can go ahead and open that, maybe even take that whole routine and move it to the other part of the file. Easily done. And I believe that split works any number of times, so you can actually see that same code file, many different parts, and pull code from several parts of it at the same time. There were lots of power tools for remembering where you'd been to recently. There's this idea of normalize, where you have a selection and it gets pulled almost to the top of the screen, leaving a little bit of space for context. So anytime you select something and normalize it, that's what happens. It will remember previous selections and allow you to reselect them. The style kind button switches the fonts of the document in order to show you what it would look like if you printed it on a laser printer instead of looking at it on the screen like this. Obviously, those fonts are less readable on the screen. They make you appreciate the bitmap fonts that I've been using in the demo so far. So I'll go back to using those fonts. All right, let me talk a little bit about the formatting of code. So one of the clever ideas in the Tioga text editor is, and the reason that you can use it for both software and for publications, is that documents are split into two parts as far as their representation behind the scenes. There's the first part of the document, which is generally the text content. Then there's a null character. And then after the null character, there's some additional data, generally binary data, that tells Tioga things like how to format the text above, whether to use bold or italics, and also allows you to add illustrations and so forth to the code. In fact, the comments in Cedar Mesa code are not even seen by the compiler because they also are stored at the document past the null character. And let me demonstrate that a little bit. So I'm going to reset this and open a smaller example. I have a little Hello World program here. And one thing to notice about this is the way that it's formatted. We have some text in italics at the top. That's how Cedar formats comments. So those won't be seen by the compiler at all. Keywords that are in all caps are shown in small all caps font, which has a pleasing appearance to it. And then the names of procedures are bold and so forth. Now in modern text editors, modern development environments, that kind of formatting would probably be generated on the fly by a particular editor, which happens to know the syntax of that particular language. But that's not what's going on in Cedar. What's going on in Cedar is that it's actually explicitly adding appearance commands to the text. And let's see here. Let me see if I can turn off the formatting for a second. So here's our edit tool again. And I think I can clear all the looks. Let's clear them. OK. And if I wanted to, I could also take this text here and tell it not to be a comment. There we go. So there's a plain text version of the document that we were just looking at. Now I don't actually want the compiler to look at this comment. So I give a command. It happens to be Control \, and that will turn something into a comment. It's gotten moved after the null character, so the compiler won't see it. And there's also a command Control M that applies the standard Cedar Mesa fonts to the various parts of the document. So there's some kind of fun things that you can do once that you know that that is going on. So for example, if you wanted to put some Greek characters in your text, maybe you're doing a little math and you've discovered that you're interpolating between several points. So maybe you've got a variable alpha, and you want to take 1 minus alpha and multiply it by, say, value x0. And then you're going to want to add alpha times some other variable x1. Now, of course, as I said alpha, you saw me type the letter A. That wasn't any fun. But let's fix that. So if I hold down the looks key and type G for Greek, now my A becomes an alpha. And there's my formula in a more mathematical notation. Now, I do have to remember that that's really an A behind there because the compiler isn't going to see the Greek looks on that. So I can't have another variable named A in the same method as that alpha. But if I like it for the mathematical purity of it, I can go ahead and do that. Another thing I really like about being able to use Tioga for writing code is that you can put pictures in your code. And let me show you that. So when I was developing the Gargoyle illustration system, I needed to do a lot of geometric calculations, including calculations on lines, arcs, and circles. So there's the open arc command again, and I've opened a module called ggcirclexample.mesa, where GG stands for Gargoyle, sort of short for Gargoyle. And I'm going to scroll down this file, and there's circle meets circle, and it has a picture in the code labeled with some of the names of variables that are going to be used in the code in order to give you a feeling of what this does. And in fact, there's another picture that goes with the code farther down. So you may wonder, how do we put pictures in code? And I'll show you that in just a few minutes. It's also worth noting that the Tioga text editor, because it is intended to be used for code as well as publications, has some built-in buttons in the menus at the top that help you out with code one way or another. So this module here is an interface, and let me stop and talk about that a little bit. One of the reasons why software reuse worked so well in the Cedar environment was that anytime you wrote some library of routines that were going to be called by another module, you had to define an interface saying what the API was, what the definitions were for the various procedures that were going to be available in the library. And so this module here, this is Cedar definitions. It's an interface, and each of the methods that you're seeing here are do not have an implementation. They're only interfaces. So when you create a circle from a point and a radius, you give it a point and you give it a real number, which is a radius, really a floating point number, but that's what they're called in Cedar, and that it's going to return an object called circle, which is of type circle. No implementation is provided. The implementation is always in a separate module, often with IMPL at the end of its name. In fact, you can have multiple implementation modules for a single interface, sometimes handy if the files started to get too large. And you could even have multiple implementations for the same interface. So if you wanted to have an experimental implementation of some of these methods, you could go ahead and do that in a separate implementation. And later on, when the package gets put together and ready to run, you can choose which implementation you want to use. Now back to the Tioga commands. If I select a piece of text and click Get Impl, that probably happened so fast that you could hardly even see it, but what just happened was that interface, the Cedar definitions, was replaced by a Cedar program, which is an implementation. And I believe it's going to refer to the interface, and it's going to export the interface. So that's how you know that this is an implementation of that interface that we were just looking at. And similarly, if you use things like the definitions button, I believe that will help you get to the definition of a particular thing. Let's see if that works. So I'll select that, click def, and there we are at the definition of the procedure that has that particular name. So all of those things just are built right into the menus at the top of Tioga and available to you anytime that you're programming. All right, let's change gears a little bit and switch to a different application. I'll just close this for now because I'm going to use it later. And I'm going to show you the Gargoyle graphics tool. I'll move it over to the left column and get rid of this object. So what you're looking at here is an illustration tool. It has a number of built-in objects. You can play with squares and circles and triangles. But what's really fun about Gargoyle is the way that you can construct your own objects. And it has a method built into it called snap dragging, which I'll show you in just a second. This is a menu of operations up at the top. And this menu was itself drawn with the Gargoyle editor using what we call documents as user interfaces. I'll talk a little bit more about that later too. And these are also menus that help you with drawing precise shapes. So the idea of the snap dragging techniques for drawing precise shapes is that you can ask the system to give you some guidelines. It's kind of like a ruler and compass construction approach, except without all the tedium that you remember from ruler and compass construction in high school. This is a system that builds all the guidelines for you. So for example, if I want to make an equilateral triangle that has a horizontal base and it is 1 inch on a side, I just start drawing, and the system is automatically giving me some guidelines because I have automatic mode turned on. And there's my equilateral triangle. And if I want to, I can also Let's see, haven't done these commands in a while. Let's see here. All right, there's drag. And rotate. And let's see if I can figure out. Not that one. All right. So that must be scale. Let me try that one more time. There we go. All right, so you've got your guidelines. You can make precise shapes. And let me show you how we would make kind of an italic letter G. So I say I want guidelines at 0 degrees, which is horizontal, and also 60 degrees, which is a little to the right of vertical. And I start drawing. And I don't need my circles anymore. There's my letter G. And Gargoyle used some of the same ideas that were used in the Tioga text editor as far as making use of the mouse buttons. So for example, if we want to take this part of the G here, so I did a middle click to get the whole edge, just like selecting a word in Tioga. I do a right click to extend my selection to this edge. So now I've selected all of these segments in Gargoyle. And now I'm going to do the drag operation. And I'm able to drag just those particular objects. And if I have my cursor here first, then I can even make use of the guidelines in order to precisely hold that part of the G along the guidelines as I'm moving it. So now let's say we wanted to take this G and let's make it purple. And maybe we feel like it's a little too large, so I'll shrink it down a bit. And now maybe we want to add that to a Tioga document, whether it's code or a conference paper. So I'll move that over here. And now let's say for some reason we want that purple G to be over here. I just leave the cursor there. I come over here and go to my, I think it's the Interpress menu. And there's an operation stuff to Tioga. Now notice this menu that just popped up. There's a lot of operations in it, but they're not in a single column, they're in 3 columns. The left-hand column means things that you can do, that you can accelerate by using the left, clicking on this menu with the left mouse button. The middle columns for the middle mouse button, the right columns for the right mouse button. And also, if you hold down Shift or Control keys at the same time that you're clicking, you can get to any of these commands here. And this particular menu has more than 12 commands, so there's some you can only get to by popping the menu up like this. But the first 12 all have accelerators. And we can see that the accelerator for stuff to Tioga is no Shift key, no Control key, and use the middle mouse button. So let's go ahead and do that. And I have to have a node level selection, so I'll double click over there. And there's our G. So very quick from drawing a picture in Gargoyle to getting it into Tioga. So I talked a little bit about this menu up here and how it was drawn with Gargoyle itself, using a system that we call documents as user interfaces. And the idea there is that any of the objects here, whether they're text objects or whether they're bits of geometry, can have some additional text applied to them which describes what their behavior should be when you click on them. And the documents as user interfaces system had kind of built-in functionality for things like the pop-up menu that we were just looking at. And let me show you some others. So here's a pop-up menu for doing fonts. And so again, after you use Gargoyle for a while, you know that if you want bold, you're gonna hit this button using the control key, and the text is going to become bold. And actually, let me show you a bit of text. I think I just start typing. Yep, just start typing. That's great. I can select that. And now if I remember, I hold down the control key, do the right click, and I'll get the largest of the bold font choices. So the more you use Gargoyle, the faster you get at operations like this because of the way the menus work. Now this idea of documents as user interfaces was used in many different places. So in addition to being able to take objects in the Gargoyle illustration system and allow them to have button behavior, you could also do that in Tioga, including anywhere that Tioga is used. So here's a commander window, but of course we know it has Tioga in it. And there is this command that we wrote called button ls, which does what an ordinary ls command does, except that in addition to listing all the names of the files in that directory, it's added this extra rectangle before each file. Now, that rectangle is an object that you can ask Tioga to put in any document. But this particular version of the rectangle has some button behavior behind it, so that if you click at it, it's going to open that particular file. Let me talk a little bit about DF files and the commands bring over an S model. Because they were another key to why we were so productive in the Cedar environment. So, of course, these days, there are all kinds of version management tools for software. There's been a whole line of them, right? So Git's fairly popular right now. There was CVS and Subversion and so forth. Cedar had its own version of those, but it was quite easy to use. The idea was that when you make a package in Cedar, you write a file for it that describes what is in that package, both what is directly in that package and what it needs to import from the Cedar releases in order to work. And so for my little Hello World file here, I created a DF file, and you can see what DF files look like. So here's hello.df. At the top of the file, it automatically puts in the name of the author of the file. I happen to be running as Eric Bier super user, so that's why it's EBSU up there. And it's going to put itself in the Cedar 13.0 top directory. That's where DF files go. So if I use the put command, what you might call commit or push these days, that's the S model command in Cedar, where S is for system. So you are modeling a system by sending it out to the file server. Then it says what files are directly part of this package. Since this is just a little Hello World program, we've only got one, the Hello World implementation file. And then it tells you what packages it imports. So it needs one called Atom and one called Basics and one called Commander, because the Hello World is going to involve typing a command in the terminal. And it needs to do some I/O, and it needs some strings, which in Cedar were called ropes. Those are the immutable strings that Cedar provides. And when I use this DF file, using the bring over command, it's going to go to this directory, get this file, make me a copy of it, and then go in turn to each of these other DF files and recursively bring over some of their contents, not all of their contents, because the using clause here says which particular modules from that package I actually need to have locally in order to do things like compile my own package, for example. And the syntax at the end, the tilde equals and so forth, a variety of different syntax was possible there to say, always get the latest version of that package, or get a version from a particular date, or only get it if it's newer than the version that I have locally. A lot of the version-oriented commands like that. So let me see if I can actually do one. So since I was one of the creators of the Gargoyle illustration system, let's see if I can make a Gargoyle directory. Looks like that may already exist, so let's try that. Okay. So a Cedar 13 version of Gargoyle. And now I'll use my findr command and see where the DF file is. There it is. And now I will say I want to bring over that package. I'll use my shift select to copy that into the command. Looks like I made a typo there. And let's see if that works. So the DF file machinery did its magic. It found the Gargoyle DF file and then recursively went into any DF files that Gargoyle needed. It copied over 366 files. And if I now do, say, a button ls in this directory, you can see that all of those files are available to me to start doing my work. And so in particular, we've already looked at ggcircles.mesa. Now it's getting the local version of that. And if I wanted to, I can get the implementation, which now gets the local version of the implementation, and I can go ahead and start editing that and make changes to the Gargoyle system. And just to get a feeling for what compiling is like, let me go back to my little Hello World program. And I'll open that. So right now it's going to say Hello World on January 24, 2019. Maybe I'll add a time to that. We'll do 10:38 a.m. I'll save the file. I'll give a compile command. Now, Cedar had powerful tools built in for figuring out what needed to be compiled. So I could probably just say Mako and it would figure it out. Or maybe give it the DF file. Nope. Not quite sure how you trigger it against a whole package, but triggering it against a single module worked just fine. So we just compiled Hello World impl, and now I can run it. And that's not what I was hoping to see. Let's try this again. There we go. And what this command does is it registers a command with the commander. The command is hello. And I think I'll give the hello command. And there's the code that we just wrote working. And I think if I give it an argument, forget how to get help. Ah, well. Get it to say what its usage is. Anyway, So we compiled and we ran Hello World program.
And Eric, if you don't mind, let me point some other uses of the DF files. If there is something specially to be compiled or so, that's figured out from the DF file. Or have you seen Eric ever linking some program? You know how many pages the linker documentation has in certain systems. Here Eric didn't say anything about linking, because whatever the linking is will be read out of that one DF file, which seems so simple.
Can we talk a little bit more about the Tioga being both a publishing tool and a code editor, and the reasoning or the motivation behind creating Tioga in that way?
I'll do my best. So as you see, Cedar gets a lot of advantage of having the same text editor everywhere, right? So once you've learned the commands, how you create a paragraph, how you make something look bold, how you apply a style to something, whatever it happens to be, then you can use that everywhere. And your motor memory, of course, learns when to hold down the control or shift key, which mouse button to press. Also, the copying mechanisms, holding down the shift key and then selecting something everywhere. Having that work everywhere, so whether it's just a field in a form on your screen or an entire conference paper, the same command is going to work, and you're going to be able to copy your text from one place to another. So I don't know how much of that was, explicitly thought of and designed in Cedar, probably a lot of it. But I do know from having used it that it was very convenient. You could pull pieces of text out of code and stick them into a conference paper if that's what you wanted to do. Take a picture from the conference paper and put it in the code. All of that stuff just worked. It also meant that if you were trying to explain to someone else, so your administrative assistant was helping you with a conference paper, you could stand next to her while she worked and say, well, you have to hold down the control key here, and that piece of text is going to move over there.
I would like to expand on this answer a tiny little bit. Remember, when Cedar was done, there weren't many other tools to look at how you could do it, which you could copy. So it's the wrong thing to ask, why are the tools done the same tools? It's actually obvious. You need a program editor. You have a text editor, so why not use that? So if you'd had to argue and to reason, at that time, you would have to reason why you would not want to do it that way.
And that reminds me, I talked a lot about copying, but it's also interesting to spend a moment or two to talk about moving and about pending delete. Right, so as I said before, the selection commands are quite powerful, and so I can select from a word to a word. Now you probably noticed that when I did that, that the text that I just selected became video reversed. And the reason for that is that often the reason that you're making a selection like that is that you're going to replace that text with something else. And the video reverse means that if you start typing now, all of that text is going to go away and something new will appear in its place. So that just comes for free, the pending delete. But now, what if I wanted to move text? So again, all of the mouse operations are going to work, and I'm just going to change the keys that I hold down with my left hand. So if I hold down the Shift key, as you know, what's going to happen is whatever I select is going to be copied to my current cursor position. If I wanted to move it instead, so I don't want this sentence to be here anymore, I want it to be somewhere else, then I hold down Control and Shift, and it goes ahead and moves it instead of copying it.
I was impressed. I've never seen Cedar before. to see how wonderful it is, and also to see where some of I've been thinking about where some of the ideas came from. Some were very old, like I think the setting the so-called clipping level in Tioga, I believe, goes clear back to Doug Engelbart's NLS system. And I believe one of the NLS people was Bill Paxton, who was the Tioga editor. Author.
Yes, he certainly worked on it. So did Doug Wyatt.
And the NLS system was much simpler, but it was very integrated. Things tended to be applicable in any possible place. When I was at PARC and Xerox in the middle 70s, the Alto had a very small memory. Each program took over the entire Alto, and things weren't integrated. We had to use simple little editors for code and fancier editors for documents often. Cedar is able to, but there were still a bunch of techniques from the Alto that did get into Cedar, like the thumb, the left-sided scroll bar, some of the ideas of selection, and finally, I think the sort of integration, the fact that you're using the same component everywhere, definitely was something that Smalltalk was pioneering. Even on the tiny Alto, they were able to just let you use a single editing tool, a single graphics tool in any possible environment. So finally, with Cedar, with the big, powerful 1 megabyte computer, was able to pull together all those ideas and then add so much more. All the graphics really was way beyond what was ever done on the Alto.
Mm-hmm.
So,
Since Paul just mentioned the levels again, I thought I'd show that in code, which has many different levels of indentation to it, you can actually click and click and click and keep getting more and more and more detail. So if you write long routines, even ones that are multiple pages long, not considered great coding practice, but it sometimes happens, you can manage some of the complexity of that by using the levels each even down into the code itself.
Was Tioga full WYSIWYG then? I mean, I guess you mentioned like once you switched the font to show the printing font, then did what showed on the screen match what would be printed?
I don't think it was completely what you see is what you get. Opening that conference paper again and putting it in print mode, you see that this is a 2-column conference paper, but we're not actually seeing 2 columns here in Tioga. That's not going to happen until we turn it into Interpress or something like that, or actually send it to the printer.
Okay.
So you got a pretty good idea of what it was going to look like, but
Tioga was
wasn't all
pretty
there.
much WYSIWYG, but in the very early times, we did not have smooth fonts. Actually, the smooth fonts were still secret, but so we had bitmap fonts, which means when the text goes from the screen to the printer, it will print with a mildly different font. And they had to be different because screen resolutions could never match printer resolutions at that time. But eventually, in further going on with Cedar, such differences got eliminated.
So you mentioned Interpress. Could you actually view Interpress files directly in Cedar?
Yes. Let's see if we can do that. Don't know if we have it here in Cedar 13, but we might. So there's a whole bunch of Interpress files. And let's look at the ones for tool glasses and magic lenses. And let's see, all right, so there it opened it in Tioga. Now, there was probably something called IP Viewer or something like that. Does anyone remember?
Oh, there's a special viewer.
How about Interpress? Okay, so there's Interpress itself. There's IP Register. Yeah, that one I would have to look up.
But those were the files that are sent directly to the printer, and the printer understands natively.
Yes. As you see, I have Interpress files for a lot of the documents in this directory. So I think what I did was make Interpress files, and then there was a printer command to send them to the printer.
It was very common to do, to look at the file for printing on the monitor. But again, because of the font problems, the characters looked a little bit odd. You didn't really want to edit printable files. You edited Tioga files. And there is also some small differences you might not even notice, that the line breaking of the files depended on the window size. And when you print, the column adjustment is different.
Okay. One thing I notice is that the interface is, I mean, obviously it's very consistent, very well thought out. It's also, because of the multiple mouse buttons, it seems to be geared towards power users. So I'm wondering about how easy is this for a novice to learn? Are the various commands easily discoverable?
Right. So as I said, it wasn't just researchers using it. The administrative assistants would use it, the artists would use it, and they were able to come up to speed. It was nice that, that you could easily find the documentation for each of the packages. And part of the Cedar culture was that you would write good documentation. And as I said, there was conventions for what you would call the documentation file. If you updated a package, then there was a convention for what you did then. You would use S-model in order to save a new copy, and then you would use a specific template in your email message to make sure that you described all of the things that you ought to describe about what change you just made and which package it was you changed. And it was a convention also to update the documentation if you'd made a change that should be documented. So the documentation tended to be pretty usable. All right, there is a package called Preview. Now let's see if it works. And there's this one. Looks like I don't have the fonts I need. But wait, it did give me a window. Okay, cool.
The ease of use for non-expert is something kind of funny. If you'd read the documentation, or if you listen to somebody explaining how it works, it sounds difficult. And one of the reasons it's difficult is because we be proud of it, and we sometimes even explain why something is in a particular way it is. But when you actually sit on the machine and you're not thinking, you just use your fingers to do the fingering for you, then you will see the logic behind it. So many commands, you can just come with the design ideas of Cedar, and you will come out, guess how it works, and yes, it works that way.
So here we are paging through a conference paper using the preview tool. Of course, the fonts are not very readable at that size, but we can scale them up. And see
So those are the full outlines
Yes, I think
that
so.
will be printed.
And of course, if you sent that to a laser printer,
The
just
administrator
fine.
could easily write a text document, but the administrator would not write a Tioga program, and the administrator would not design a chip with the chip design editor.
Right.
Where, given the very technical nature, the commands might have been more technical. But they still used as much as possible the same pattern as the Tioga stuff, but kind of obvious. If you wanted a metal line, you pressed M, and if you wanted a transistor, you pressed T. You know, it came up with some other set of commands which were application specific. So not absolutely everything was completely integrated, but a lot.
Right. Could you talk a little bit about, since you were one of the developers of Gargoyle, so could talk about your involvement in that, how that project started, and the other people that you worked with?
Sure. Gargoyle was a lot of fun. So Gargoyle, as I said, is an illustration tool, and you saw a little demo of it earlier. And it grew out of my dissertation at UC Berkeley. We had a conference paper about it at the SIGGRAPH conference in 1986, I think it was. So that's about when we were working on it. And as far as my dissertation was concerned, I was really interested in the snapdragging technique, the kind of ruler and compass on steroids technique. But I also really enjoyed building software that other people would use. And we definitely have a long tradition at PARC of using the tools we build. In a way, Cedar is one of the glowing examples of that, because this was not just a programming environment where you did something that you would write a conference paper about. When someone built a new database or a new text editor or a new graphics editor or whatever it was, everyone in the community would start to use it. So we noticed that people who were using Cedar wanted to put pictures in things, and that it would be great to have a way to draw them. And so Ken Bier in particular worked on Gargoyle with me. I think I probably got some help from Maureen Stone and others as well. Of course, we were standing on the shoulders of people like Michael Plass, who built the Cedar Imager. And so there's a really powerful library that has built into it polygons and spline curves and clipping and resolution independent graphics, so that once you got it to look right on the screen, you'd probably be able to get it to print too, and all that kind of stuff. So adding an interactive end on top of all of that graphical rendering power made a lot of sense. And folks like Steve Walgren, who was a staff artist at the time, picked up Gargoyle and used it for lots of the things he needed for graphics at PARC, whether he was making brochures or posters for the PARC forum or whatever it happened to be. So we had a lot of fun seeing what the artists were able to do with Gargoyle. Now, my dissertation was actually on using the snap-dragging technique in both 3 dimensions and 2 dimensions. So there was eventually a Gargoyle 3D, and one of the delightful surprises of that work was that some of the same mouse button and keyboard button commands that you can use to precisely draw objects in 2 dimensions work in 3 dimensions as well once you have the guidelines. You don't actually need to have a 3-dimensional cursor moving around in the world. You can instead see yourself as pointing a line from your eye through your cursor into 3-dimensional space that then you then snap to a 3-dimensional guideline, or the surface of a sphere, which is the 3-dimensional analog of the circles in ruler and compass construction, or onto the surface of a plane. And so just by beefing up the alignment objects so that they were 3-dimensional, you could quickly make precise shapes in 3 dimensions. And when I was working on that project, I'd make a video once a week and drive it across the Bay Bridge to UC Berkeley, where my thesis advisor at UC Berkeley was waiting to see what I'd done that week.
Who was your thesis advisor?
Carlos Secan. He and Brian Barsky kind of had assembled a graphics lab with lots of graduate students there in Evans Hall at UC Berkeley.
Did you say earlier that you wanted to show some more features of the language?
Ah, yes. Let's do that.
Such as multiple return values?
Sure. So let's look a little more closely at GG Circle Simple. So some interesting things about the Cedar language. One interesting thing is, as you say, you can have multiple return values. So here's a routine that we were looking at before. Circle meets circle, and the purpose of this routine is to take 2 circles and see if they intersect, and if so, at how many points, right? And circles can intersect at a single point. If they're tangent, they can intersect at 2 points. If they overlap, they can intersect at no points if they're concentric or far from each other, and so forth. So this routine is going to return some information about that intersection. Now, in many languages, you're only able to return a single object, but that's not true in Cedar. As you can see here, we've got the returns keyword. Here are the input arguments. We're going to take a circle named circle1 and a circle named circle2. Here's the type of those objects. And then we're going to return 3 different objects. We're going to return an array of point objects. We're going to return the number of times that the 2 circles intersect, which will be a number between 0 and 2. And we'll return a Boolean, which will be true or false, saying whether or not the system thinks the circles are tangent. And the way this actually happens is that just by naming these return values, you've created a variable that's local to this procedure that you can begin to use. So let's use the find machinery here. There we go. Already starting to assign a value to point sub 1. Now, another interesting thing to notice here is this syntax for ranges, right? So we know that this is an array. Not only do we know that it has 2 things, but we're going to call the first one 1 and the second one 2, right? So whereas most arrays in code start counting at 0, for whatever reason, we decided to start counting at 1 here, and we made that explicit in the declaration there. Even a little odder is, in most programming languages, you just say hit count's an integer, right? But it's so easy in Cedar to say, well, actually, there's a constraint on this integer. We can tell you right now it's going to be 0, 1, or 2. So that was actually explicitly put in the declaration there. And the funny little left arrow here is the assignment character in Cedar instead of a regular equal sign. And we're able to give the return value a default value right there in the header of this method as well.
Did Cedar use a lot of non-ASCII standard characters?
Not a lot, just a few. And yeah, the left arrow is one of the strange ones.
So there were special keys on the keyboard to type those characters?
Yes, I believe so. When we ported Cedar to the Sun computers, to the Sun operating systems, which happened in the late 80s, obviously we had to do some key mappings so that the keys that we would expect on the Cedar keyboard, which was the Alto keyboard, would have analogs on whatever keyboard you were going to have with your Sun workstation. And I actually was one of the people who did that keyboard mapping. I also helped to port the viewer's window system to the Sun operating systems back around 1987. We had this project called Windows by Winter, where we were trying to get viewers working on the Sun microsystems, before December 21st. I don't remember whether or not we succeeded, but I'm sure we came close.
So the D machines all inherited the Alto keyboard and the character set as well.
That's what I remember.
Yeah. Okay. Chris.
The way I remember it, the left arrow was the only character which was problematic on keyboard, and that got replaced by colon equals. And once you write colon equals, you don't have any special characters which are important to the language. And when I left Xerox, I did for years to come, still occasionally today, I write equals, and I mean with equals that we do a comparison and not an assignment. But in Cedar, the colon equals versus a single equals is so much more intuitive than having 2 equals or just 1 equal. And I can add a few more feature on the Cedar language, if that's okay with you, Eric.
Please do.
One, Xerox might have been inventing object-oriented languages with Smalltalk. When Cedar come out, there is no object-oriented feature on the language at all. However, there is enough primitives that object-oriented programming has been the norm. I am not aware of a single program which didn't use the object features of Cedar, but they were done with the primitives which were basically function variables and closures and nested functions. So lambda expression is something which occurs without having lambda mentioned in the manual. It's very simple. You make closures in nested functions and you have them. Another thing Cedar had from the beginning were multi-threading. I am aware of one program in Cedar which does not use multi-threading. It's possible there are more, but the one I do remember, that's the compiler itself.
Actually, threads were even in Mesa before Cedar.
Oh, you're absolutely right. A lot of things were even in Mesa before they were in Cedar. Cedar made them easy to use.
Yeah.
And it's so natural, but it's hard to point out the individual little features. Like the module Eric was mentioning, that is also coming down from Mesa, but it has been a lot of simplified in Cedar, I think, without losing power.
By the way, I found another nice example of adding font appearances in code. So here's a variable D2, but it actually represents a distance squared. So by giving it superscript looks, you make it clear that, oh, well, that's, of course, that's a distance squared. What else would D squared be? But yeah, there was a powerful error handling mechanism. Just lots of support for throwing exceptions, catching them again, re-throwing them again. That was all in Cedar. And then the synchronization primitives for dealing with multi-threading.
It's interesting you mentioned the error handling, because that's more than just error handling. Since in early Cedar, the debugger was written in Cedar, and the debugger figured out, well, everything about variables. So the Cedar language allowed self-inspection, and this was frequently used. What's now very modern, like runtime type inspection, that has been in Cedar all the time. Instead of having objects, there was a type which was called ref any. So that was bound to pointers, and if a pointer was called a reference, that meant that at runtime you could figure out what the type of that pointer was, and your program could run select statements according to what type a variable really is.
So you mentioned the Cedar is strongly typed. Was there a concept of generics, or was that something that you were able to live without in the Cedar language?
There's one feature of generics which really make them useful beyond what you do in Cedar. In Cedar, you do not program with generics. What you did is you were programming with a ref any. So that thing could be whatever it had to be. It did do the function of generics with one little exception, and that was the performance. Because if you use generics like you do them today, you would have zero overhead for some extensions, and that little detail was not in Cedar, but having had a Dorado computer, one wasn't missing that.
Right, I see. So let's say you wanted, you would just have an array that would have ref any's to other things.
That's certainly
types.
something one could do.
Yeah. So you also mentioned that people tended to program in an object-oriented style by building up from the primitives that were already in the language, even though it did not explicitly support object-oriented programming in the language definition. So you mentioned that that was done with a combination of closures and nested functions.
There is a pattern which is found in many, many programs, that the function has a ref any argument. So what you did is you wrote your code by calling a function which has a very generic argument like refany and could give into that function whatever you wanted to give into that function. And also the fact that functions were nested allows you to use the outer variables of your functions. So by using function variables, you could create pretty tough to read patterns where a callback used a callback back into the original program, which might use a different callback back into the function which was originally called. And these patterns, you kind of had to learn how they look like, but they had the power one needed.
Yeah, so it sounds like even though Cedar Mesa was explicitly a strongly typed language, with refany you could actually program in a more loosely typed fashion.
This is absolutely true, and it is an explicitly typed language in the sense that everything has its type. refany also has a type refany. It's just at runtime it can be a whatever other type pointer you want to assign to that refany. But program text is strongly typed, and if you use the runtime typing, it was still strongly typed, but it was then typed at runtime.
So I just noticed something interesting in the code that I'd forgotten about. So we have this type circle. It's defined to be a reference to a circle object. We have a circle object, and it's defined to be defined in another module. And when we make a new circle, it's of type circle, but we're making a new circle object. So there was this kind of distinction between the thing and the reference to the thing that shows up in the type declarations.
So is the reference to the thing treated as a different type, or is there sort of a notion of a type and a reference to that type? There's always a reference to that. You can make a reference to that type.
It's a separate type in the sense that it has its own name. You can refer to it. You can ask if this variable is a circle. You could ask if it's a circle object.
Right, okay.
But
And
in spite of being a separate type, the language allowed to shortcut when you have you want to follow a chain of pointers. You didn't have to explicitly follow the chains. So in that sense, you could type a dot, which could either follow a pointer or be a field of a structure.
I wanted to say just a few words about the Dorado Cursor,
Oh, sure.
just because I remember that follow. This is not a Dorado Cursor, obviously. This is an X-Windows cursor. But one of the interesting things about the Dorado was that it dedicated some of its CPU time to drawing the cursor on the screen. Every few cycles, the cursor would be updated. And what that meant was that the cursor was one of the most reliable objects on the screen. Even if there was a problem and the rest of Cedar had frozen, the cursor would still move around, track your mouse nicely.
Oh.
Your application may have fallen behind and have 10 events that it hasn't processed yet, but nonetheless, the cursor would rigidly track your hand. What that also meant was that if you wanted a really reliable way to communicate with the user that's going to work even when some things have gone wrong, you could do that by putting a number in the cursor. So various kinds of error messages were just numbers that appeared in the cursor, and we all learned what those numbers meant. And I think 815 was a really important one.
Yes.
So here you have it, some little user interface detail only experts could use. But you can add more on your last words, but my last word would be I wish I had it.
Yes. And Cedar had a suspend mechanism. So you could go back to a previous state. You could checkpoint and you could roll back.
The entire environment? Or
It was essentially you were suspending and resuming, right? So you were storing your state. And as a joke, one year someone wrote a little song to the tune of "Let's Do the Time Warp Again" from Rocky Horror, except it was "Let's Do the Rollback Again."
anyone else have any last words?
Thank you, Eric.
Yes.
Yes, thank you very much for showing this.
You are very welcome. So one of the things that I was just demoing without talking about it was this command openr, these commands openr and findr. I believe the R is for release, and open in the sense of open something for editing or viewing,